All right, welcome, Full Stack Web 16, to another glorious day of JavaScripting. We're going to be working on the this keyword and prototypal inheritance. If we go look at our JavaScript fundamentals day, you'll see that you've got these videos that you were supposed to watch. Eyebrows. So in JavaScript day 3, we have explained the 4 principles of the this keyword. Also, describe and use prototypes, constructor functions, the new keyword, and pseudo-classical inheritance. Wow. To build a small object-based video game. Wow. Yes, we will be able to do that this afternoon. It's crazy. This is a big day. All right, so let's talk about the this keyword. The this keyword is a construct of scope. It lives within the scope, and it's something that helps us gain understanding. So if you watch the video from Ryan, he talks a little bit about this, talks about how it points to things. One thing I wanted to do is like a little object lesson here. So I picked out a fun picture of some trees here. Now, if I were to say, given this forest of trees, and I said, man, look at that tree, you'd be like, which tree, right? And I'm like, that tree. And then you're like, I don't understand. Is this a stupid trick question? Like, that's the hard thing, is like, we have to start describing the tree, right? Or I can do you a favor and I can say, well, specifically, I'm talking about this tree. Oh, that tree. Yes, this tree. And so in this case, I'm now pointing to this tree over here out of the forest. Well, my friends, this same concept exists in JavaScript. It's basically a contextual thing based on scope. So the forest, this whole area, is considered window inside of JavaScript. The forest is the window. And the window is where all of our JavaScript, at least in the DOM, lives. And we're going to be talking about the document object model next week. But as a little precursor, we have to address it because this is where our code lives in the browser. So the window is everything that we're always talking about. It's always the forest. So if you don't have context of the tree, if I didn't tell you where this was, then you could only assume in our conversation that I'm talking about this forest. Does that make sense? Because it's like, if I say this, then you go, okay, well, you must be talking about the forest, because you're not talking about anything specifically. Okay, so that's how JavaScript works on a little fun tree level. Let's go see how it looks inside of code. So what I'm going to do is jump over here, and let's just console log the this keyword and see what we get. So I'm going to come in here. Let me give you this code, sorry. There you go. So I'm going to say console.log. I'm just going to slap in this keyword and find out what the heck is going on. Now, let me turn on my behavioral settings so I can hit the run button and not have it autocomplete in CodePen. Notice here it says, hey, this log was too big. Let's go see what it looks like in the real console. So look at the real console, and looky here. We get the forest. So this is the forest equivalent. So this is all of the trees here. That's what the window object is. And so if we open it up, oh, it takes a little bit because look how big the forest is. It has many trees in it. This is really crazy. Like, this has a lot of things that even a lot of developers don't even know about and might not even know about. And so in this case, the window is the forest in which we're working. And we need to be able to point out specific things in the forest so we can gain context. Okay, so that's the this keyword right off the bat. Like, that's what it is. It's pointing to the forest. And we're trying to figure out, well, which tree specifically are we trying to change or look at? So this concept is one of 4 principles of identifying the this keyword. And we're going to call this window binding. So window binding basically states, if you do not have any more specific use of this keyword and pointing it in a specific way, it will always point back to the forest. It will always point to the window. This is bad behavior, but it's how we have to live inside of JavaScript. We can prevent this behavior using strict, and I'll talk about that shortly. So let's see how this works inside of a function without just saying the this keyword. So remember that this keyword is a construct of scoping. So if I come in here and say function, and I just say greeting. So here's my normal looking function, nothing special here. Then I use my fancy invoke word. I invoke you, greeting. I come in here and I'm going to say console.log this. And let's see what happens. So I'm going to get rid of this and use this. So I'm going to hit save and run. And notice what happened. The log is still too big. If we go look at it under the console again, wah, wah, we still have our window object. So see what's going on here is like, when I first started programming, I often would think that the this keyword would point to greeting. Like greeting would have some context, right? Like I'm in a tree, it's called greeting. But the reality is that's not true because I have not told the this keyword how to be greeting. I've just said, tell me what the forest looks like. And so this is where things get a little confusing and we have to like think about the this keyword in a bigger context and go, wow. Now we can prevent this from happening by using strict. So we can say use strict like that. And what will happen if I save and clear and run, I'll get undefined because the this keyword has not been defined by anybody. I've not pointed it anywhere. I'm still just trying to look at the forest. But now, instead of trying to go out to the window binding, it stops at the function and says, nope, I'm not going to let you go any further. So use strict, again, another awesome case for use strict. Another good reason to use strict when you're coding JavaScript. So in this case, this is called window binding. This is something we want to avoid and something we will continue to see throughout your career. So if you ever see a big old nasty log, you goofed on your binding. And usually this is an indicator that something went wrong. But at least now you know about it. Again, this is kind of like the important in CSS, where I'm saying, don't ever do this, but be aware of it. Same thing with window binding. Okay, so now that we've got window binding under our belts, we understand that we're looking at the forest, like we're looking at this. Let's get into specific trees. So the next binding we're going to talk about is called implicit binding. Implicit binding. Now, whenever I hear the word implicit, I want you to think about the word automatic, okay? Sometimes people don't understand that word or not seen it in programming. In my case, I want you to know that it's automatic binding. It just happens for free. Let me put some comment buffers here so we can see this stuff easier. It's always nice to do that for the next developer, and in this case, the learner. So we have implicit automatic binding is our next concept here. So I'm going to build, since I'm such a nerd, I like Lord of the Rings and stuff, let's build a Hobbit object. And so inside of here, this is an object literal. Remember, we're using an assignment operator, so some curly braces. Within these curly braces, we have key value pairs. And my key is going to be name, and I'll have a value of, we'll say Frodo will be our first Hobbit here. So in this case, actually, let's do Sam. I like Samwise. Okay, so we'll come in here and we'll say food. And you know Sam loves taters. And then he also likes to cook. So let's give him a cook method like that. Now remember, we can use an anonymous function that we can use as our value so that it will then invoke when we call the key, which is a cool feature. Now, pop quiz, what is a function called inside of an object? What is a function called inside of an object? That's right, a method. Good job. So this method allows us to run a function inside of an object when invoked. So if I come in here and I want to console log something, so I'm going to say console.log. Let's try an interesting log. So I'm going to come in here and I'm going to say Samwise likes to eat or likes to cook. Or let's see, Samwise cooks. He's cooking. Cook some taters. I probably don't need to have that capitalized. So in this case, this is just a hard-coded string, right? Like there's nothing really helping us right now. So let's go ahead and try to invoke our method on the Hobbit object. So if you recall, all we have to do is reference Hobbit like that. So it's going to grab our object. We then use dot notation to jump into the method. So we're going to say cook. And then we use our invocation, our parentheses to invoke it. And let's see if this works. So I'm going to hit save, clear, and run. So you can see Samwise cooks some taters. Okay, Josh, this is not new stuff. I know. Hold on. So if we come in here, what if we wanted to have this be dynamic to our object's information? What if we wanted Samwise and taters to actually be dynamic here? Well, we learned about our string template literals, or template literal syntax. And so we can actually use our $, because I used backticks. What if we did something like that? So let's try this out. Now, Samwise is the value, right? We want to have the key. So if we come in here and hit name. Now, before I hit run, remember, I always want to talk about this. Is this going to work? Before I hit run, is this going to work? Okay, I'm seeing some nopes and some nah, but do you have any reasons why? Ooh, Joe says it's out of scope. Hamza says it's undefined. Okay, let's try this. Let's hit run. Here we go. What the? CodePen cooks some taters. Interesting. So what the heck is, why does it say CodePen? Well, that's because on the window object in CodePen, they actually gave it a name. So that's just unique. If we were to run this code on your local browser, it would not say CodePen. But it's kind of funny because CodePen does have a name on its window here. So CodePen cooks some taters. This is probably a little confusing if you didn't read and didn't watch this stuff before, because you're going, well, wait a second. It seems like, let's do something else that's not going to be in CodePen. Food is probably not going to be in CodePen. So if I come over here and do food as my value, let's see what this reads out like. Let's see. Let's see what my console's saying. Okay, so we come down here. Food is not defined. So if we come down here, but wait a second, isn't the food right here? So this is the conundrum again of looking at the forest, right? So over here, if we look back at the forest example, we have our Hobbit object here. Well, really, it's not the Hobbit object. We're staring back at the forest. And so that's the confusing thing. When people first start programming in JavaScript and they use the this keyword, or don't know about the this keyword, they start using object literals, and they're like, wait a second, I want this to be a little bit more dynamic. And the answer is you can't do this, because notice these curly braces, my friends. So let me show you. Remember our block of scope. Remember all the things we've been talking about this week. These little curly braces right here are preventing, they're introducing a new scope. So our cook method now has no idea. It's like a brand new baby. It doesn't know who its mama is. So in this case, we have to tell it who its mama's is, and we have not done that yet. So how do we tell it what its mama is we use the this keyword. So now let's go take this out here and see how this works. So we're going to say this dot name and this dot food. So now we have said, no, I'm not talking about the tree, the forest anymore. I'm talking about this specific tree. That's what we've done now by saying this. It's as if you're, in that forest having a conversation with somebody, and you walk up to a tree and you point at it and you go, no, this is the tree. That's what we're doing by using the this keyword here. So now let's see what happens. Save and run. Samwise cooks some taters. There we go. That's the desired result that we wanted to see. And that is all happening because of where we invoked our method. So the hard and fast rule of implicit binding is look to the left of the invocation, and there you will find your this keyword. So in this case, cook is our invocation. If we look to the left of where we invoked it, there's Hobbit, and now we know our this keyword. So Hobbit is this for the cook method, okay? So that is called implicit or automatic binding. This is always with implicit binding at least, this is always going to be attached to objects in JavaScript. Okay, so we talked about window binding, how it's always happening and everything's always trying to point back to the forest. And then we learned about how we can actually point directly to the tree by invoking a method inside of an object. So let's take a breather here and say, are there any questions that we can help out with? Okay, so Cecil says, this looks as its closures and sees what variable is referring to, or are you telling it what the context is when you invoke it? Second part, Cecil. I'm telling it what the context is when I invoke it. Brandon says, why not use hobbit.name in the cook function instead of this? Ooh, so Brandon says, why don't we just reference the object? I like your thinking, Brandon. So if we come in here, we hit save. Is this going to work, by the way, before I hit run? Oh, we're seeing a lot of yeses. Let's find out. It does indeed work. But here's the problem. If this name ever changed, we could never use Hobbit again. And oftentimes we're creating objects from scratch, which we will do later today. So this would not help us. But I love your thinking, and you understand that the context of the scope is there. So good job. But this allows us to be dynamic. Okay. Let's see. Oh, I did have a question for you. I did see Marius created a JavaScript 3 questions thread. Would you prefer that I just stare at that thread and then the main channel can just be whatever you want? I've had some feedback talk about that, and I want to make sure that you guys are having the best learning experience. So what do you think? Would you like to have just a questions thread and that's the only thing I look at? Or do you want me just to keep following the main thread? Here, I'll put it out. I'll say, stay in a thread, and then just say, I'll just say yes or no. Just say yes or no right there. Oh my goodness, you guys are so 50-50 all the time. Oh my goodness. Okay. All right. Here's what we'll do. Every time I open it up to questions, I'll pop open a thread. How about that? So here's what I'll do. I'll say questions for window and implicit binding. Okay, there's the thread. Ask here. And put, that's where I'll look at. So if you did something, put something in there really quick. All right. So let's see. Quick function, okay. Okay, I think I answered all the questions though. So ironically, no other people are asking questions in that thread. All right, so we're gonna keep moving forward because we have so much content to cover today. So that's implicit binding. It's automatic. Look to the left of the dot and understand it's a construct of scope. All right. We're going to move on to explicit binding. So explicit is the opposite of implicit. So implicit means it's automatic. Explicit means we forced it. So we control this. And this is extremely powerful. So instead of having to open up this forest of trees and be like, well, I went over and I touched this tree, so you must know what tree it is. Now I can actually put a laser pointer on it and say that tree. So explicit binding allows us to use that laser pointer and specifically tell where we want to go. So I'm going to come back here and we're going to start looking at some explicit binding. And after explicit binding, we'll probably take a break. So with explicit binding, let's say that we had another object. We'll say const, and we'll say it's a person. And it's like a generic person object. And so we're going to put it in here. We'll say name. and we'll just say it's anything. We'll say it's Bob. So in this case, we have a Bob person. And this Bob person, maybe that there's another array or something of skills. I'm making this stuff up, but it's basically right out of the training kit. So we got skills. We're going to assign the value of, and we've got some skills that we're going to do. Let's say Bob's a programmer, because we're all trying to become programmers here. So HTML, CSS, and JS are some skills that Mr. Bob has. So at this point, we now have kind of two separate entities, right? We've got a skills over here. We've got an object literal over here. And so now we're going to have a function that's going to introduce Bob. So we're going to say function, introduce. And when we want to introduce ourselves, we want to introduce our skills and our name, okay? So we'll come in here and we'll say console.log. Of course, we'll use our backticks now and say, hello, my name is Bob, and I like to program in HTML, CSS, JS. I always like to do the explicit string first, like just the stupid, no smartness here, just to find out this stuff's working. So I come in here, I invoke my function, introduce. Let's see if our string works. Now, remember, I don't want to see the previous stuff, so I'm going to go ahead and just comment out my invocation. I'm going to save and run. Okay, hello, my name is Bob, and I'd like to program and blah, blah, blah. Okay, cool, it's working. So nothing new here. Let's introduce something new. Now, right now, this isn't very dynamic, right? Not anything I'm doing isn't really coming from this person object. And so this happens quite a bit in JavaScript, especially in libraries and frameworks like React library. We can actually bind our functions to different things. It's really valuable. You'll see it a lot more. Even next week, when we start talking about the DOM manipulation, you'll be using quite a bit of binding to get things done, explicitly binding to this keyword. So we're going to basically take two things that don't belong together and bind them together. So it's pretty cool. So let's try this out, see how this works. So what we can do is, like, what if we came in here and instead of Bob, we wanted this to be dynamic. So it wasn't just Bob. It could be brought in through variable. And in this case, right now, Bob is not going to work, right? Because that's the value. And again, if I try to say name, we already learned from our implicit binding that is just not going to work. But what if I say this dot name? Because we did that up here and that fixed that problem. Is that going to fix this problem? What do you think? No? Okay, let's try this out. Save, clear, and run. And look what we get. Our old friend CodePen is back from our window binding. So remember how I taught you about that use strict? So we could stop that. We could say use strict to prevent our window binding. Let's see if this goes. Clear, save, and run. Okay, so at this point, we're getting an error in the console that's saying, hey, this dot name is undefined. So if we want to just double check, make sure that that's really happening. Cannot read property name of undefined. Cool. That is the behavior we wanted. So at this point, we're kind of stuck. We're not allowed to do implicit binding anymore because we don't know what object, we don't know what tree in the forest that we're pointing at. So we can actually use functions. So I'm going to give you this link right here. Function methods, I should say. Click that link with me if you will. Or follow this link or just watch the screen. But in this case, remember how I taught you to read the MDN documentation a couple of days ago. We have properties, we have methods. So there are three big methods that all functions have, and they all have to do with explicitly binding to this keyword. So in this case, we have apply, bind, and call. These are three ways that we can bind the keyword. Let's look at call first. So the call method calls a function with a given this value and arguments provided individually. So if we look at the example demo here, we have console log new food cheese 5, and then they have dot name. So in this case, function product, name price, and they're actually building a constructor function here. But in this case, they're using call to go ahead and bind to this keyword from our product. That's pretty crazy. So this one is, we're going to get closer to this in a second, but before we do, let's go figure out how we could actually bind the this keyword to the function. So notice that they did it. If we look at the syntax here, notice where they're doing it. They're grabbing the function name and then they're binding it on the invocation. Interesting. So we've just been invoking things like this forever, but now we can introduce a method of function. So remember, a method is just a function inside of an object, and we just proved it right here because now we have all these methods that we can reference, these three methods. So in this case, introduce is a function, therefore we can use call on it. And so now we can actually pass in the reference that we want to be bound to it. Interesting. So I could come in here and say, well, this keyword is the thing that I want to be bound to it. So I'm passing in person, this object, this curly brace right here, between these curly braces, this is my new tree. I'm pointing to that new tree in the forest. So let's see if this works. Hit save and run. Aha, hello, my name is Bob, and I like to program in HTML, CSS, and JavaScript. Okay, so we figured out that this context, and we know that if we kept adding things here, we could just add them in here. But there's another interesting part to these call, apply, and binds. And so if you look at the syntax down here, it actually lets you pass in arguments, right? Because it's still a function. It still wants to receive parameters, like we still want to pass things to it. And so call, apply, and bind, just say, hey, look, one little rule, you've got to pass in this argument that you want to be bound, and then a comma, and then anything after that, you can pass in your normal arguments. That's just fine. So it's still, like, it doesn't kill the ability of a function. So we could pass in our skills array if we wanted to. We could just come in here and say skills. And then we can receive skills. Notice that I don't have to receive the this keyword because it is bound to the this keyword. So I don't have to pass in person up here to receive it. It's not an argument. It's a binding. So hello, my name is this name, and I like to program in. And so then we can come in here and open up our curly braces, comment this thing out, and pop in skills. Let's see if this works. So I'm gonna hit run or clear and run. Here we go. My name is Bob, and I like to program in HTML, CSS, and JavaScript. Now, one interesting nuance here is that when we use call, if we come in here, the optional value, arguments for the functions, it's going to pass it all into one big chunk. So if we go look at our skills, and if we tried to like separate these skills out, for example, like what if we said skills 1, skills 2, and skills 3? Well, if we tried to say just HTML and CSS and JavaScript separately like this, so if I said skills 1, skills 2, and skills, whoop, shortcut key, like this, let's see what happens. Save and run. Well, the problem is call only passes in one big argument in this case. So HTML, CSS, and JavaScript are not separated individually. So one of the other function abilities that we have in our methods is apply. So the apply method calls a function with a given value, and arguments are provided as an array. Oh, that's interesting. So it's basically the same thing, except that now we can pass in an array. So let's go over here. Let's go ahead and keep call just so you can see what it looks like. Comment it out and introduce apply. Now let's see what happens here, or if anything happens. Run. Aha, my name is Bob, and I like to program in HTML, CSS, and JavaScript. Notice that it already put them out in the skills for me individually because it's an array-like object. So that's just an extra feature that is built under the hood with apply. That's pretty cool. If you're familiar with some of the new ES6 syntax abilities, though, we can actually go back to call. This is just a side note of fun, but we could use 3 ellipses here, and this allows us to spread, it's called a spread operator, allows us to spread out these values individually as well. So if I hit run, you can see HTML and CSS and JS. It feels like apply, but in this case, I just use a spread operator. Now, this is too advanced. This is out of scope. But those of you that are interested, now you've seen it once. I'm not going to talk about it more, but I thought that's pretty cool. And it's totally valid. But apply is basically doing that. And that's the only difference, by the way, between apply and call. So apply separates the values into an array like, what does it say specifically? As an array or array like object. Well, we'll just say an array since they say an array. Whereas call does not. So that's the difference between call and apply. Call just brings them in. Okay, the last one I want to talk about, and then I'll open up to questions. The last one is bind. Bind is really interesting because if we look at it, the bind method creates a new function that, when called, has its this keyword set to the provided value with a given sequence of arguments, just like apply and call. So that's interesting, but one thing that's new here is we can basically hold the this keyword in stasis for a little bit. So let's check it out for a second. So I'm going to come over here. And I'll just make a new comment here, and I'll just say, bind is basically use this later. That's how I think about bind. And so if we come in here, we'll set up a const, and we'll say, you know, use later. And in this case, we'll then assign this to be an invocation, just like a function expression. We'll say introduce dot bind like that. And then, of course, it's going to look like everything else we've been doing. Skills. And so notice that if I don't have anything running right now, save and run. No issues, no errors, like no big deal. And that's a good thing because maybe we don't want to use this just yet. But let's say we have some other function that runs and we do want to invoke it. Well, then we can invoke it later and say introduce, or use later, I should say. Keep saying looking at that, but we just invoke introduce, or sorry, use later. And now with use later, save and run. There we go. Notice it has the same ability as call. It just passes in the one value. But again, I showed you that sneaky cool syntax that allows us to kind of get around that if we need to, if you need to pass in separate values. And there we go. So this is really cool. And you'll be seeing this quite a bit in React. Basically, you'll make a decision between an arrow function or a bind. But those are the two big players right now when it comes to binding this keyword. What about today? What about like what you need to learn today? Just know that we can hold the this keyword inside of a function and you're good to go, okay? We'll just keep layering this on as we go in our curriculum here. But I just want you to understand that there is a thing called bind and it can be used for later and housed inside of a function. Okay, at this juncture, let me open up a thread and I'm gonna say explicit binding thread. Okay, go ahead, pop into this thread and ask any questions. Okay, Cecil says, in your opinion, bind versus arrow function. This is one of those big boss questions, meaning if your lead programmer says, hey, we use arrow functions here, then you say, I will do it. If your lead programmer says we use bind here, that's what you do. The only difference is really the syntactical sugar. So if you look at an arrow function, those arrow functions can actually cause confusion sometimes because they're so succinct. While you're writing them, they're a joy though. So that's my opinion. Follow the big boss. Nathan says, if the array inputs using apply is longer than the available spots in the template literal, do they just not get used? Yeah, so they just won't get used. Yep. Try it out, Nathan. Hamza says, what is the reason why the arrow function gives you the ability to not use explicit binding in React? So the arrow function actually passes in the lexical this keyword from wherever it was invoked. So it's pretty awesome that way, and also dangerous in some ways. But that's out of scope for what we're talking about today. Pun intended. Joshua Disney says, why would you use call then if apply is the same thing but better? If you only need to pass in one argument, that's why. That's about it. Kenneth says, can you pass skills 0, skills 1, skills 2 to call? Yes, you can pass. Well, if you pass it, it's only going to be one value. So if you try to pass those in individually, but then you're being really hard coded, right? Like you could only accept those 3 skills. Bradley says, can you show how you'd use the arrow function? I want to, but we just don't have enough time today. I have so much to show you guys, and I don't want to introduce like the spread operator, but maybe there's a video in the past I'll give you guys later where I had a PM do a whole lesson on arrow functions if you'd like. So I'll give that to you. Just today is so crazy. You'll see. We're not even scratching the surface yet. Okay. Any other questions? I love that you guys are so hungry about this arrow function stuff, but I can't take a tangent right now and describe it. But I can later. We can give you a video later for that. Okay, those are all the questions in thread. Okay, Alex says, why would you bind versus writing something like this? Introduce person later. Because when you're creating objects, Alex, so we'll be talking about that very shortly here, but basically you don't even have a reference for person maybe. Maybe you have 400 person objects. So that's why you'd want to bind it for later. So it's a bigger concept that we're going to get to. Okay, our brains are definitely fried. We've gone over our 30 minutes. Let's take a 5-minute breather. When we come back, we'll talk about the new binding and get into prototypal inheritance. So 5-minute break. All right. Welcome back from your break. While we were breaking, having a good discussion about communication and channel. This is one of the larger cohorts we've had. There's literally 103 people on this channel. And so I would like to suggest that we use a thread for just questions, and then we can use the main channel for all the other fun stuff. So I have since created that thread. It's called questions thread for JS3. I've starred it. I don't know if you can see my star, but it should be at the bottom of our chat currently. So please, any questions I may have missed or any questions you want to put in, I'm just going to be looking at that thread always, but I'll still use the main channel for communication. So it's like, hey, what do you guys think is going to happen next? Like, I need that feedback so I can see that we're following along. So best of both worlds. We'll keep trying to do this. Okay. So usually I like to give you some time to play around with this code, but the sheer amount of content that we have to cover today, I won't be able to do that. So make sure you go watch those objective videos if you haven't, because there are code challenges in them if you want to keep pushing yourself further on this information. Okay, so the last binding is called the new keyword binding. Okay, so new. And this has to do with building new objects binding. So I want to review, let's do a quick review. Window binding, it's always there. It's the forest of trees, right? Whether you like it or not. So we have to be careful about it. Then we learned about the implicit binding. This allows us to look to the left of the invocation of a method. How about that? And there you will find your this keyword context. So Hobbit is this for the cook method, right? We learned about that, specifically with objects. Then we learned about being explicit with functions. So with functions, we can actually control which this keyword is getting applied. And so we did a kind of a silly example, just one object, but we talked about the different abilities of that one object. So we learned about call. So call passes the this argument and one parameter of data. Well, it's actually arguments, right? Because we're inside of a invocation. And arguments, say argument, and then this applies the separate values of an argument into an array if you pass in an array. And then bind allows us to use it for later. So we learned all about those really cool abilities. Again, hold on to bind. We'll get it later. Don't stress about it now. But this is something that is going to be really helpful for you later. These two also are helpful, but you'll see all three as you continue to program. The new keyword you're going to see quite a bit today and in the future. So with the new keyword, we're introducing bigger concepts. So that's why I've actually moved it to the end, because it bleeds into the next concept extremely well. And so that concept is the building of objects using a function. We haven't done that yet, but it does. It's going to continue forward in all the things we're doing with our fundamentals lessons today. So you know how we had our consts and we have some object inside of there. Well, I'm going to go off the training kit. We have Jerry object that we've been using, little Seinfeld reference here. And we're going to assign that value to something, right? So maybe we'll pass in a name value pair, like name Jerry, right? Like that's what we're used to. But what if we wanted to create an object that had similar attributes and methods, and I wanted to make many of those objects? Well, right now, it'd be really laborious to try to make a bunch of different objects that had the same abilities. So we can actually introduce a function to help us do this for us. And that function is called a constructor function. Constructor function is simply a function that builds an object. So in this case, we're going to go right off the training kit and say cordial person. So we're going to build a cordial person object. So in this case, notice that I had a capital in front of there. That was not on accident. That cordial person is allowing us to say, okay, hey, next developer, I'm actually using a constructor right here. So this is a great tip off to the next developer that you're actually constructing new objects. Okay, at this point, that's really the only syntactical difference. But now we're going to be introducing the this keyword using that new binding. So at this point, they're not really connected at all, right? But we can connect them using this syntax. So what I'm going to do is I'll just comment this out. We'll make a new one, say const Jerry, assign the value of new, so there's that new keyword, and then we're going to actually reference our constructor function, cordial person. I want to make a new cordial person. And so I can invoke my constructor function like that. And then at this point, I'm going to pass in something that I want to use later. But so in this case, I'll pass in Newman. We're going to make a method. So what I'm going to do is I'm going to come up here. I'm going to say this dot. Now this is new right here. This is all the fun new stuff of using the new keyword. So and a constructor function. So in this case, what we're doing is we're saying this dot greeter. So we're setting up our own context of like what our tree is going to look like in the forest. And we're going to pass in a value. So in this case, we passed in Newman, right? Well, we've got to receive that argument into the parameter. So we'll say greeter. So we can pass that argument through. So in this case, we're just saying cordial person, pass in a string of Newman. So that's just simply went up here. And Newman is being held here. And now we're going to use the this keyword to say, you know what? This is going to have a key value pair of greeter, and the value is going to be Newman. This will make more sense after I log it. Just give me a second here. So we'll say this dot greeting, assign the value of hello. So we've got these two pieces. This is basically our Hobbit object. Like this isn't that crazy looking. It's just name and a food, right? We just have greeter and a greeting. The only thing that's weird here is we're using the this keyword like that. And the reason we're doing this is because we want to reuse this object over and over, or this creator over and over. So I'm going to say this dot speak like that. Assign the value of our function, just like we did in our Hobbit thing. I'm going to say console.log, use my backticks. And now I can go back to what we did with before. We could say greeting, right? Hello. And then we can bring in our greeter. So in this case, we're going to say Newman. So it's going to say hello, Newman. Let's see. Did I goof anything up? Oh, I got to use the this keyword, of course. So this dot greeting, just like we did in our function above, we've got to use the this keyword because we're in a new scope of context, right? All right. At this point, what we've done is we've created a new object. Let's see what we've done. So I'm going to say console.log, and let's just see what the heck we did with Jerry. So clear, save, and run. So you can see here we've created a new object. Isn't that cool? So Jerry was just a const, right? It's just a description. But what made it an object is we said new cordial person. So it says, okay, run through this and create something new. Oh, and by the way, pass in this string. So in this case, we now have this ability to call this method. So I could say Jerry dot speak. And if I run this function, or I run that method invocation, look at that. Hello, Newman. Isn't that cool? So in this case, we have hello, Newman. Well, what if we wanted to quickly recreate this for Newman? Now, because we have our constructor, we just copy and paste. We make a Newman reference and pass in Jerry. And now we get all this extra, we get all this stuff built in because all it's going to do is go and say every time it says new, it's going to invoke this constructor function and run again. So now I could just come in here and say Newman speak. Save, clear, and run. And there we go. Hello, Newman. Hello, Jerry, right? So this is extremely powerful because we are now creating reusable code. So we didn't have to write out these fully fleshed out objects for each one of these people, right? Jerry and Newman, we didn't have to write them out individually. We just said new cordial person, and then we actually were able to utilize some things that already existed. For example, the speak method. And so, of course, I could do this times 100. And this would allow me to not have to write out 100 unique objects every time. Now, this is the beginnings of something really cool that we're going to talk about shortly. But at this point, are there any questions? I don't see any questions in the thread regarding the new keyword. So let me use my arrow or my annotation tool to just draw out what happened. So first off, we set up a little storage. We used a const, and we said Jerry. Then we said new, and new is specifically tied to our constructor function. So cordial person. These are tied together, right? Because of the name, we invoke the function. On invocation, we passed in a string value of Newman. So Newman comes up here and gets plopped into this parameter, right, as an argument. The argument comes through, and then here's where it gets really interesting. We're using this dot greeter, and where did this keyword come from? Like, how are we able to use it? Ding, 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 because of the new keyword. So the new keyword allows us to use the this keyword in this context because we're basically setting up a new scope of rules. So there's those curly braces, and these curly braces are all tied to the new thing that we just created. So pretty awesome, because now we can just copy and paste over and over a bunch of new cordial people and get all these abilities for free because it's just outputting new objects for us. This is the beginning of some object-oriented patterns where we can borrow and expand on objects. Okay, any questions about the new binding or constructor functions? In this case, we're just building a new object, quite literally, like this is just a new object, right? And it has a name reference by whatever we set it up to. So Jerry, Newman, and so that's why we can say Jerry.speak and Newman.speak. Clint says, are constructor functions only used to create objects? Yeah, I mean, that's their point. They're meant to construct objects. That is their purpose. So constructor functions are meant to build. Andrew says, can constructors also place objects into other objects within the constructor? Yeah, we can have constructorception, but more often than not, you're going to be extending or inheriting from other objects. So there's patterns we can follow. I'm going to show you some object-oriented patterns today, even though a lot of the hotness right now in JavaScript is functional programming. And we'll be talking more about functional programming as you get closer into React. But you still need to know some basic object-oriented patterns. Josh Disney says, what if there's a key in a constructor function that you don't want inherited? Then, I mean, it's really up to you. And you know what? That's actually a really good question as to why object-oriented programming sucks. So, Josh, you hit something right on the head. Why a lot of people don't like object-oriented programming. So the answer to that is a big hot topic right now, and why a lot of people like functional programming better. Now, if you hear what I'm saying and you're going, what is the difference between functional programming and object-oriented programming? We're just not there yet. They're just paradigms. They're just things that you can go Google right now. We're in fundamentals mode. So just trust me, go Google those things if you want. You might be a little overwhelmed by what you Google, but we will get you there, slow and steady. Okay. Is it garbage collected? Oh, you're talking about anything that's not used. Yeah, if it's not used, it's not going to hurt you, but it is extra. So oftentimes we will put methods outside of our constructor. So we'll bring these and we'll pop them outside. So let's talk about that. You guys are all talking about the next thing, which is prototypes. So the new keyword really lends itself to the next hour of conversation, which is prototypal inheritance inside of JavaScript. So we are now done with the direct this keyword portion. I'm going to hit save on this, and then I'm going to actually open up a brand new window because it really, like, we need this just to be brand new. It's awesome, this new stuff I'm going to show you. So we're going to say prototypes, and then I'm going to save this. I'm going to set up my settings so I can get that run button back. I'm going to add this to this FSW16. Okay, let me give you this new link. Okay, there's the new link inside of the main channel. Okay, so prototypes. We're going to be using this keyword like crazy throughout, and we'll just keep calling it out. But we needed to have this keyword foundational before we could go into this, because this keyword is used all over the place. But remember how I showed you Jerry and Newman? Well, we're going to go a little bit further than that. In the training kit, I think we've got the Flintstones, or just random people called Fred and Wilma and Pebbles from Bedrock. But we're going to start goofing around with that and show you how we can inherit properties. So first off, let's set up our object. So we'll say const Fred, going to be assigned the value of, and we're going to introduce our constructor. So we're going to say new parent constructor. Okay. So in this case, this is how we can invoke that. Now remember how we passed in Newman or Jerry, right? That's what we just did. Well, I'm actually going to do something a little bit more advanced, and we're just going to pass in a straight up object literal. So we can do this. We can actually do this. So I'm going to just introduce a new line right there. And all we're doing now is we have key value pairs. And so I'm going to say, okay, age, let's say, I think Fred's probably like 35. I don't know. Name, we'll put it in strings here. We'll say Fred. We'll say location, Bedrock, and we'll give him a phrase. And he always says, yabba dabba doo, just like that. Yabba doo? I don't know. So in this case, we have this Fred object, right? Now, well, we have the beginnings of a Fred object, I should say, because this wouldn't work right now in its current state because we're trying to invoke a parent constructor. So what I'm going to do is I'm going to build my constructor. So I'm going to say function. Now remember, what is one of the telltale signs that you're actually using a constructor function? Do you recall? That's right, the capital letter at the front. So in this case, we're going to say parent, like that. Open and close our invocation, and then we're going to have our curly brace. So I'm going to just do this really quick so we can remember where parent is, and remember it's a capital P. This is our constructor. So at this point, we've learned, just from our simple examples before with Jerry and Newman, that we can start matching these and building this up. This is just a pattern. So we can actually pass in these attributes. So this is like an object, right? So I could call it that. I could say like object, but it'd probably be smart to call it something that it is. In this case, it's attributes, right? These are all attributes of a Fred object. So in this case, I've now received attributes. Let's see what we have at this point. Console.log attributes. Save and run. So look what happened. We just received age 35, location, name, Fred. Like it just received this, and it's saying it's an object, the capital O. And that's because it is, right? See these curly braces? We quite literally made an object. It's an object literal. So it's saying, look, I made an object, and this is stuff that's being passed through. Well, the cool thing is we have attributes. We have access to these things. The thing that's not cool is we're not recreating an object at this point. We're just console logging what came through. So let's make sure that this thing can be built. So remember, we used the this keyword that came from our new keyword. So this dot age. And so what we can do is we can assign that to our attributes.age, right? So we can say assign the value of, and we know that attributes.age is actually 35 in this case. So attributes.age, there we go. And in this case, that's going to be basically this objects.age is going to be assigned the value of 35, right? So if we come in here, because remember, it's just 35 that's coming through. So we'll just do this times 4. We'll say name and name, location and location. So you're seeing that we're doing kind of a pattern here to allow us to create this new object. You'll see why this is important in a little bit. Right now, it seems a little bit like not that dry. We're repeating ourselves, but not really. We're creating something new every time. So let me go down here and console.log Fred. Now, before I do that, let's see what he looks like before we did this. So I'm going to comment this out, save, clear, and run. And notice that we just have an empty object because new parent did indeed invoke, but nothing actually got created. And that's because we didn't run these little lines yet. These lines, so I'm going to save and run, you can see the contrast between the two. So now I've actually created this object for reuse. So now I can actually reference Fred. So I can say Fred.age, right? Or Fred.name, or Fred.location. And so if I save and run, I get my answers, right? Well, in this case, I didn't spell location correctly. So got to be careful. So if I hit run, 35 Fred, there's Bedrock. Okay, cool. Well, again, if this stuff didn't exist and I tried to reference those values, if I hit save and run, you will see I get undefined, undefined, undefined. So that constructor function is actually doing quite a bit for us. It's creating that object for us. So don't discount this, even though it looks like we're repeating ourselves. We're not. We're actually creating something new. Are there any questions at this juncture regarding our constructor function or what we're doing with this keyword? Okay, there we go. Any questions I can answer? I'm looking at the questions thread, by the way. I don't see anything in there. Okay, if I do, I'll come back to it. So in this case, Fred is a new parent, has these abilities, right? Well, let's make another object. Let's make Wilma. So we'll come in here, say Wilma, new parent. Maybe she's 35, I don't know. Wilma, Bedrock. And doesn't she get mad at Fred sometimes? Like, Fred? So in this case, if we were to run this, console log, we can see if this is working. Let's just change the age just so we can see if there's a difference. Let's make her younger. I know my wife would appreciate that. So we'll say run. So in this case, we have Fred and Wilma are both unique objects now that have these abilities. Now, at this point, you could still kind of call me out and say, look, you're still having to write these objects out. Like, what is the value of using a constructor? Well, very astute of you. But more than that, we can now start sharing methods across multiple objects. So we could come in here and we could say, well, what if we introduce something like a speak method? So we said this.speak. Find the value of a function. And in this case, we could then console.log. And in this case, our backticks come in and we can just say this dot name says, and then we can say this dot phrase. Spelling will be the death of you, I promise, more than anything else. Okay, so at this point, they're now sharing something between them that they didn't actually introduce inside their object. This is where it gets really cool. So I can come in here and I could say Fred.speak and Wilma.speak, and we should see different values. Save and run. So Fred says yabba dabba do. Wilma says Fred. So in this case, you can see already, wow, now we're sharing methods. So this sharing concept here is the beginning of object-oriented programming, being able to share like methods and reuse them over and over. Even though both Fred and Wilma did not have a method inside of their object creation, like in their description right there. Isn't that cool? So now you can see why this is pretty cool, because they might have similar age, name, location, and phrase as far as keys, but they don't have matching speak keys. We had to actually introduce that in the constructor function. Whoa, that's cool. The problem with this, though, is that anytime you build an object, if it is inside the constructor, it will try to instantiate all those things, or at least it'll try to reference all those things you can slow down and program. And so what we often do in programming these kind of things is we extract this method out of the constructor into the prototype. And here's where it gets really interesting. Okay, but I see a couple questions in threads, so let me stop. Daniel says, when you console logged just the attributes keyword, why were they shown as nothing? Nothing has been invoked yet. So when I logged just the attribute keyword, because when this stuff didn't exist, it wasn't building a new object yet, Daniel. It was just straight up passing in the object literal here, which didn't have any information passing. So again, if I try to run this right now by deleting all this, I just get a bunch of undefines because the two-pass compiler doesn't know where they exist. So we have to set them up as a reference, and that this keyword allows us to reference what they are because we're using new, right? So new parent allows us to use this. So this is, we're basically setting up our forest of our parent object, and we're saying, okay, you are here, we're providing organization. Otherwise, we're just saying, look at the forest. Like this is just like, if this is commented out, we're just saying, look at the forest, and nobody knows what it is. But when we specifically add these things in, we're saying, well, this tree is this tree is that. Hopefully that helps a little bit, Daniel. Nate says, can a new object be required to have specific properties from the parent? So in this case, usually you are controlling this, right? Like somebody else is not controlling this, at least at this point. Like this is author time. So hopefully, you would be using something that both people need, Fred and Wilma. So in that case, Nate, you control your future here. But again, kind of what Josh Disney was talking about before, which was, what if you didn't want that? And that's where we get into issues where object-oriented programming can get really ugly really quick. Cynthia says, could you go over the constructor one more time? Sure. So the constructor function is a function that we name with a capital letter at the front, specifically for the next developer. Like there's no other value there. It's just letting the developer know it's a constructor. It receives parameters. So, well, in this case, arguments from an invocation. So const Fred, and then we say new parent on this invocation. So remember, if I were to delete this, that's all it looks like by itself, right? It's like just very simple. We're saying new parent, but we're passing in an object literal so we can get a lot of information. Because remember, variables can't do much for us, but objects can do a lot. So in this case, we're passing in these 4 objects. The 4 objects are then passed into attributes, and then we distribute those objects out in creating a new object with this keyword. So the left side of our assignment operators, this is creating the new object. The right side is just giving reference to the values down here. Hopefully that helped, Cynthia. So Hamza talks about, can you introduce the method outside the constructor? Yes, we'll talk about that right after this. Andrew says, how does a constructor handle an attribute list that doesn't match up exactly with the constructor? Okay, so what if we put in something here? We said, rock, rocks, and only Fred has it. So if we hit save, clear, and run, if we look over here, we look under the console, and we refresh everything, notice it's not really doing anything. It's not harming us because we're not using it. Now, What if we brought it into the constructor though? And when we said this dot rocks, assign the value of attributes dot, and then we have our rock down here. So let me make sure it's consistent because we want consistency. And now we know that Wilma does not have a rock in there. So let's see what happens now. So I'm going to clear it and run it. Okay, no harm, no foul, because nobody's using it. Now, if we went down here and we said Fred.rock, will it show up? Save, run. And you can see rocks does indeed show up. Okay, now the final question is, what will happen with Wilma? Save, run. There's our good friend undefined from our 2-pass compiler. So that should answer your question. I think it's a valid question, but now you've seen it in action. By the way, I hope that you're doing this on your own. Like in the afternoon when you have a question, I hope that you're trying these things out instead of just trying to ask the internet. Go try it out yourself. It's going to make you way better. Okay, Cecil says, can you define author time / lexical scope? You've been referring to it, and it also comes up in other coding literatures. Yeah, so lexical scope, if I were to just say it right now, lexical scope is the scope that belongs specifically to the function that was invoked. That's how I would just define lexical scope. It's very ownership based. So when I say lexical scoping, I mean the scope in which you invoked on that specific function that belongs to that function. Okay, Jamie says, can you use a dot type thing where it creates this dot whatever for each attribute to the constructor? That was supposed to be star dot star. Let's see, I'm a little confused. Sorry, Jamie. I think you're trying to say, can you use a type thing where it creates this dot whatever for each attribute? So yeah, I mean, up here you can, but not down here. Is that what you're saying, Jamie? So like when you make Fred, we're not saying this dot. We're only using it up here in our constructor. Sorry if I didn't answer your question. Okay, pass all the attributes, and the thises are automatically created. Oh, I see what you're saying. No, because we have to specifically call them out as properties and key value pairs. But I like what you're thinking. I think you're thinking, man, that's not dry enough for me. I want to loop through that or something. That's what you're thinking. I appreciate that. So what if so now let's go outside of our thing. Let's come back to this. We'll hold off on questions. I think we answered all of them though, or at least addressed them. And now what we're going to do is we're going to extract this out and utilize that prototype and start talking about the prototype. So what I'll do is we'll extract this out and then we'll take a break and then we'll talk about prototypes. So here's how you do it. We can reference parent because parent is our constructor. So we can just say parent. And now here comes the really cool thing today. Well, everything's been really cool, but prototype. So parent.prototype allows me, just this one line, allows me to grab the guts or the insides of this constructor. So if I were to grab this drawing tool, this right here, that's why I had this little comment line. From curly brace to curly brace, this is representative of the prototype of parent, okay? So when I say parent, so I'm saying referencing parent, dot prototype, I'm actually saying grab everything inside of here. This is a special keyword inside of JavaScript that allows you to manipulate the DNA, if you will, of an object. Constructor specifically in this case. So we're grabbing the innards of this and we're going to actually change it permanently. So prototype is super scary and it's also awesome, meaning you can actually change the default behavior of the browser if you wanted to. I'm being quite literal. So if we come in here, if I go to the console, and I'm like, let's look at what array does. So if I were to say console.dir, so I can list out the directory of an array. Notice it's a capital array because what? What are capitals? They're constructors, right? So if we come in here and we can see, oh, look, that's how arrays work. So now you see even more under the hood why JavaScript is just a bunch of constructor functions right here. Look at this, capital A array, and look at all these methods inside of it, right? You know these methods, or at least you know some of them. Map, reduce, filter, they're all here. Well, guess what? I could actually make my own method on array, the primitive array. We call these things in JavaScript primitives. So I can actually come in here and say array dot backflip. And in this case, I could actually manipulate my own, and I could say, well, first off, I got to grab the prototype because that's what I was showing you. So prototype. So basically, I'm saying grab the guts of array, and now I'm going to add my own function. I'm going to call it backflip. And I can actually add my own function. In this case, I could say console.log just did a backflip in this case. And so at the end of this function, I can go in here and just hit enter like that. And now what I've done is and at least in my browser, this isn't going to hurt your browser or the internet, thank goodness. But I've actually permanently added a method to arrays. Isn't that crazy? So if I come in here and say console.dir array, and I open this thing up, we try to find where's our backflip at, where'd it go? Should be on here somewhere. There it is. It's on our prototype. So you can see there's my backflip, right? So if I come over here and I make a new array, so I'm going to say, const new array, assign the value of, and then remember, all you've got to do to initialize an array is just send it to square brackets, right? Let's just do that. And so then if we said new array, you can see it's just an array, right? Well, if this is all true, I should be able to now say new array dot backflip. Oh ho ho! Isn't that crazy? I literally changed the makeup. Like I changed arrays, at least in my browser, to now include backflip on its prototype. I changed JavaScript primitive, which is very bad, by the way. But I just want to show you that you can do anything in JavaScript. And so that prototype allows us to literally manipulate the insides of our constructor here. That's crazy. So what we can do, since we made this object, we have free reign to manipulate this object. So I'm going to say parent.prototype. So now you should know through that experience that we're just grabbing the insides of our constructor here. And I can say speak, right? And just copy and paste the same syntax. Like that. Make sure the assignment operator's in there. And delete this out of the constructor. Because remember, the constructor, we want to keep it clean. We want the constructor to be name value pairs only if we can, and have our methods separate. Okay, but it should still all work. So if I hit save and run, there it is. Fred says yabba dabba doo. Wilma says Fred. And we are good to go. And of course, we can make as many methods as we want. So I could just make another method down here, like do math or something. Oops. And I could pass in something and just say, A plus B. Receive two parameters, A and B. And then I could come down here and I could say, Fred, do math 1 and 2, right? Save, clear, run. And there's our 3. So these methods can go on for forever and ever and ever. Of course, if you're doing that, we probably need to think like, what are we trying to do here? But look at array, right? Array has so many methods. So even JavaScript uses those. Okay, let's take a 5-minute break. When we come back, we're going to talk about expanding this even further for the last 30 minutes here. 5 minutes. Okay, come on back. We're not done yet. We got some awesome stuff to do here and pushing our knowledge forward. So, quick review of everything we've done in this prototype stuff. Talked about const Fred being assigned the value of a new parent. In this case, parent is our constructor function. Our constructor function then accepts attributes from our object literals. And those object literals are then created into a new this keyword context here, which allows us to recreate objects over and over so it's not specific to just one object. We also learned that if we don't access the object, we're okay. It can also be in there. In addition to this, we talked about expanding our methods out to the prototype or the DNA. Like whenever I see prototype, I just think it's the innards of our constructor function. It allows us to build objects from that. So if you ever see that prototype keyword, well, guess what? You see it every time you use MDN. So if we go to MDN, I told you we talked about it today, and here we are. So if we look at array, excuse me, well, looky here, array.prototype.whatever. And so here's the pattern. This is for every object in JavaScript, by the way. So let me prove it to you. If we go in here, we can actually see under the hood of our console, we can actually look at this inheritance pattern and see where this all comes from. So where prototype is DNA, how could we actually see that family tree inheritance? Well, there's a special thing called dunder proto that allows us to see that. So let me explain to you this. In this case, let's say we have a person, and this person has a child. This person's child has attributes from this person. So maybe they're tall, they have blue eyes or black hair, or I don't know, anything that could be passed down as a trait to a child. So in this case, there is a line, right? We call this family trees or pedigree, right? In this case, this line right here is pointing and saying, you're a direct descendant. We can actually test our DNA, right? And see who our parents are biologically. So biologically speaking, this pattern already exists in nature, and we often mimic those patterns in programming because that's where we came from. And so often programmers look at nature and go, well, nature did a good job. Let's see if we can put it in computers. So in this case, prototypal inheritance is just that. Inside of JavaScript, there is actually an original parent called object. And this object parent has specific abilities inside of it. And those specific abilities are name, value, pairs, and methods, just like anything else we've been looking at. And then what happens is they pass that information to multiple children, okay? So these multiple children all have their own different abilities and attributes, but here's where JavaScript is different than other languages. JavaScript actually passes those inherited attributes down, and they're not copied. So that means it's kind of like CSS, where at the top of your cascade, it inherits down, right? And it didn't, but in this case, it's quite literal. You're taking these attributes, and it's like, oh, you already have this attribute. I don't need to duplicate it. In other languages, like class-based languages, oftentimes you will see that they will actually copy the parent. So they'll actually take the original parent, like this. They'll say, I'm going to make a clone of you, and then I'm going to give you more attributes. JavaScript doesn't do this. JavaScript actually inherits them down in a family tree to more and more and more and more. Okay, so let's see how we can see that inheritance pattern. So just this one person comes down here, and this family tree. Well, this family tree line is called the proto line. Dunder proto. Dunder meaning double underscore, so 1, 2, proto. This allows us to see that inheritance, the family tree, if you will. So let's prove it. Console.log. Actually, let's do dir, so we can actually see these things. I'm going to say array, just like we did before. So there's array. If we open up array, you can see there's the Dunder Proto. So Dunder Proto is actually pointing us to function. Wow. So are you telling me that arrays are actually fancy functions? Yeah, I am. So if we come down here and open up proto, now I want you to notice something right here. Prototype is not the same thing as proto. Just like your attributes, your physical attributes are not your family tree, right? Like you have your own attributes, you have your own sizes and your own shapes and your own looks. They're all different. That's prototype. This is your makeup. This is who you are. Proto is your family tree line. It's your pedigree. It's your family chart. So let's find out where array came from. It came from function. Okay. Well, look at that. There's function. There's apply, bind, and call. Oh, cool. So they're all in the same family tree. Awesome. So look at this. If we scroll down, look at the next Dunder Proto that we see. It's object. The OG right there, that's object. It's a capital O. So if we open this thing up, we notice that there's no more Dunder Proto here. We've hit the end of the line, if you will. So when someone says to you in an interview potentially, could you explain to me how everything is an object in JavaScript? You could say, oh, I would love to. Let me describe to you object-oriented programming. In this case, we're going to be using the Dunder Proto to show family tree inheritance. They're going to be like, what? So if you can bust open a console with them and walk them through a Dunder Proto inheritance tree, they're going to be blown away. Like, oh man, you really understand your prototypal inheritance. And then specifically, each item is going to be the prototype, its DNA, or the makeup of itself. So that's pretty cool. And this is quite literally how everything is a descendant of an object inside of JavaScript because of prototypal inheritance. Okay, so what about object literals? So if I say const, new obj, assign the value of an object literal, name FSW16. Yeah, that's quite literally an object. So let's find out what it looks like. Console.log or console.dir, new obj. Well, look at that. It's an object, and its Dunder Proto specifically points just one inheritance level low. So object literals are quite literal. There's no inheritance pattern that we can trace beyond just one, but it still had to get the originals from it. So hopefully your mind is exploding here and you're going, wow, everything really is an object in JavaScript. But now you know why, through prototypal inheritance. Okay, let me see if there's any questions about what I just talked about. All right. Does prototypal inheritance help save memory as well? Well, when we start inheriting, which we're going to do right after this, it actually can be a huge detriment to your application if you don't watch certain things. And so oftentimes object-oriented programming can cause issues if we get too nested in our inheritance patterns. So we already saw array was already inheriting from function and object. So it has to keep in memory all those things at all times, right? So what if we extended it even more, right? Then there's even more rules we have to remember, at least we meaning the browser. So the more that we nest, the worse it can get. Just like we did in Java in pre-processing, right? Remember, don't go past 5, that rule. Similar things exist in JavaScript where you don't want to be extending your objects too far. Again, some would even say this is an anti-pattern in the future, the things that we're going to show you here, but you at least need to know about them because people do use them. People do use what I'm about to show you. Okay, so what I'm about to show you is extending our parent inheritance into a child constructor. Okay, so what we're going to do, don't want to lose that. We've got all this cool parent stuff, but what if we wanted to create a new object that had all of these things, but we only wanted our parent objects to have these abilities and not another subset of another abilities? This is a very common pattern. And so we can introduce a new concept here of a child. I want to put the child up here so we can keep it up here. And so we'll say Pebbles is a child of Fred and Wilma. We'll say that she is going to be a new child. Pebbles is probably 2. Pebbles, bedrock, phrase. And we'll just say, I can't remember if she says anything. We'll just say mama. Okay, so in this case, we have Pebbles, but she is a child. She's not a parent. We want her to have child attributes. Well, let's start building that constructor out. So we've learned we can say function. So we'll say child constructor. Child. We're going to pass in a bunch of attributes, right? We still have attributes that are coming in. So I could say child attributes, just to be more clear. I could call it attributes, but it's always nice to have some difference so you can see the difference between the two. And at this point, let's say console.log child attributes. Let's see what happens. So I'm going to go ahead and just knock out all these things down here so we have a clean slate and hit run. So same thing that looked like when we did our console log of our attributes inside of Fred, right? The problem is we would have to recreate this whole thing inside of here. And that sucks because we've already done that. So what if we could gain access to the this keyword up here to allow us to gain all of the prototype of our parent inside of our child? Ooh, that's object-oriented programming. We're basically borrowing from other objects to get something done. So with our child constructor, there's something we can do that I taught you just barely, and it's how we can explicitly bind to this keyword. So what we can do is we can actually invoke parent. So say parent dot call, okay, because we're just going to pass in one big argument, our child attributes. Do you remember the first argument that is required? Ooh, John already posted it. So John said this. So we're going to pass in the this keyword that belongs to child because we already got that this keyword from new, right? Like this is the new keywords reference. So that's why we can actually just say this. And then we're going to pass in our child attributes because that's our parameters that we want to pass in, right? Because we want to build a constructor out of these. So at this point, we now have access to those pieces. So what we've done is we've basically gained access to all of the this keyword references inside of here. So what does that mean? Does that mean Pebbles now looks differently? Let's see. Console.log Pebbles. So I'm going to hit clear. I'm going to get rid of this console log since we don't need it anymore and see what Pebbles looks like. So Pebbles looks like an object. And notice she doesn't have rock, so it's undefined. That we already understand that. That makes sense. So can we actually reference values? Can I say pebbles.age? In this case, let's see. Clear and run. 2. Okay, cool. Pebbles.location. Save, run. Awesome, bedrock. Well, cool. So basically, with this one explicit call, we've now gained access to all of the this keyword goodness inside of our parent. That's awesome. Okay, well, what if I wanted to get speak? Let's try that out. So I'm going to come over here, and I'm going to say pebbles.speak. Save, run. Not saying anything. Come down to my console log. Wah, wah. Pebbles.speak is not a function. Okay, crap, I don't have access to my methods because the this keyword doesn't give me access to my methods. Shoot, so how do I access those methods? Well, it gets a little tricky, but it all goes off of that prototype. So if I come down here and I reference child, just like these guys, right? We've already discussed this. So child.prototype. Now remember, prototype is the guts, the DNA of this scope. So in this case, it's between these two curly braces. So we're saying this prototype. Well, guess what? The insides of this now have access to all of this stuff, right? Okay. So what we're going to do is we're going to introduce a new method from object. This was like day 1, but you probably didn't realize it. So let's go to object. Inside of object, we have these methods, right? Look at all these methods. There's quite a bit. There's one called create that I want to look at with you. The object.create method creates a new object using an existing object as the prototype of the newly created object. Whoa. Think about that for a second. The object create method creates a new object. Okay, we already know what that means. So it's curly braces, name value pairs, using an existing object as the prototype. Okay, so the prototype. So Hamza asked a question earlier in the thread that I just responded in chat. And he said, can't we just do .speak? And the problem is, if we do just .speak, it's not tied to the prototype. So let's see what happens. Let's come back in here and let's try this crazy object.create thing. So object.create, remember, we're now going to grab parents.prototype. Because that's what it said. We have to be able to create a new object from another object's prototype. So we're going to take the guts of prototype. Well, guess what? The guts include methods. There's the light bulb, hopefully. Because at this point, we're now accessing the prototype inside of here, and we're actually creating a brand new object. So that's pretty crazy. So now, if I wanted to use pebbles.play or .speak, let's see if it works. Clear, save, and run. Hey, hey, Pebbles says mama. So now Pebbles has access to the full gambit, the full structural pieces of our parent constructor by nature of our call and our prototype. So what if we didn't have call? Would this still work? Let's see. Save and run. Undefined, 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 undefined. And that's because we still need that this keyword in the constructor. So in this case, parent call and prototype are both required to get that inheritance pattern that we're trying to mimic. By the way, this pattern is called pseudo-classical prototypal inheritance. It's a mouthful. Pseudo-classical meaning it's pretending to be classical in its pattern, and we're using prototypal inheritance to accomplish it. Again, this could be considered an anti-pattern in some places, but the concepts are really good for you to understand now. So when you do get into functional programming, you're going to be fine. Nathan needs a digital hug. Here you go. Come here, Nathan. Come here. Bring it in. We're going to be okay. All right. Let me see if there's any more questions over here. Okay. Roxanne says, I looked at the MDN documentation for Proto and found a ton of giant red boxes saying not to use it. What gives? Do we only use it for diagnostic debugging? Yes. Good job. Good inference there, Roxanne. We only use it for debugging. We don't use it for code. Like, I don't want to see, like, MDN does not want you to see or to use this, even though you could. Don't do that. Big red boxes. Because we only want to use the prototype and not the inheritance chain. So very good observation, Roxanne, and you're 100% right. Only diagnostic and debugging. That's it. Okay, Chelsea says, what if you didn't want the child to be able to do math? Well, the good news is just don't run that method. So it's actually simpler than you think, Chelsea. I like where your head is, but the answer is just don't call that method if you don't want to do math. David Flack says, could you give a visual demonstration for what is happening with parent call this attribute function? Sure. So, and we're by the way, this is it. We've now plateaued of the difficulty today. We're done. So now I'm just going to answer questions and review. So that's why I'm saying that, so you don't think, oh my gosh, is there stuff we need to cover? Nope, we've hit the end. So at this point, why would we do this though? Like, it seems like, why is child constructor even doing this? Well, I haven't really shown that to you just yet. So let me show it to you and then we'll walk through it. Oh, and Daniel, actually, your question goes right into this. Does child not get access to the methods of parent because they are methods or because they are part of the prototype? Because they are not part of the prototype, specifically, Daniel. Randy says, couldn't you just use that object create for the whole child object? So I did use that for the whole child object. And I just reassigned its prototype to be the parent prototype. But here's why it matters, Randy and Daniel, is because I can have specific methods reserved just for child. Only child can do, and this is why we even do this. So I could say child.prototype.play, right? Which could play with something. And inside of here, I could say console.log backticks, right? And just to show you how cool this is, I can use the this keyword from my parent, so this.name, and that's because of my explicit binding of call, plays with their toy, right? And so I can introduce a new thing called toy that nobody else has except child. So in this case, I could come in here, say this.toy is assign the value of child attributes dot toy. And that only Pebbles has this, right? And then I can come down here. What is going on with my code? Oh, did I forget something? Oh, double curlies, wow. Oh, there we go, open curly. So Pebbles, let me come in here, boy, and then let's say that she has a rock doll. So in this case, Pebbles has a rock doll, but what's unique about Pebbles is that she's a child, and only child has the ability to play. Unfortunately, the parents do not have that ability because just like our other binding with our with closures and everything we've talked about, it only goes one way. This is actually good behavior because otherwise it'd be chaos. It'd just be pure chaos. So it's good that we only have one directional this way. But in this case, if we run this code, we've got to come in here and say pebbles.play, right? And let's see if it works. Pebbles plays with their rock doll. It worked. However, if I were to run this code after this line of code, is that going to work? What do you think? You think that'll work? I'm kind of setting it up, aren't I? So let's see here. So I'm going to say run. Pebbles says mama, but no longer can Pebbles play because if we look at the console, Pebbles play is not a function. And that is because it does not exist yet with our this keyword, right? So we used this.name and we can't use it. So we've got to make sure if we use anything like that after our prototype has been set up. So that order like actually matters in the lines of code. This line of code must be above. So we are, must be above any new methods for child. Let me put some notes in here. So we'll come in here and say binding of this keyword of this keyword to parent. All right. And then down here, only child can see this method. Parent cannot. Okay. So there's some notes to kind of back up what I'm saying, and you can read it later. Also in here, we are recreating the child prototype to include everything in parent. So that's why this is unique. Like that's why we can't see anything afterwards, because only child's prototype has this. Parent's prototype is unaware completely of play. And again, I couldn't just come in here and say parent.prototype.play. It would override the original method. So really interesting stuff right there. So if we hit run, we bring it back in, Pebbles can now play with the rock doll. Now it doesn't matter where I'm putting this stuff. I'm just putting it here close. Now if we brought it all together, brought everything back in to see if everything still worked. Let's see. Clear, save, and run. And there we go. Everything's working, including our undefined rocks from Wilma, which is exactly what we thought would happen. Now, what if we did Fred.play? Let's see what happens here. It's not even going to show up because it's erroring out at the bottom, right? So if we go to our true console here, Fred.play is not a function. And that's because parent has no idea that it exists. So that's why this pattern has been used in the past for projects where you want specific subset of abilities over here in this object, in this constructor. Then you have these subset of abilities, and then they share from each other when they need to. And that's when you start getting object-oriented programming. Okay. Let me talk about the assignment, and then I'm going to come back to the questions thread for those of you that are chomping at the bit to get to the assignment. So over here, we have a project in JavaScript 3, and this is going to be a really fun day. So prototypes, basically, so I'm not going to skip over this, but it's very just like kind of a review and Google thing, or just look at the CodePen that we did. But I want you, in your own words, to describe the 4 principles of this keyword, just so I know that you understand them. So that's what this is. Very simple. We're using this keyword like crazy inside of prototypes, so it's kind of a double-edged sword here. Okay, so inside of here, we're going to be making an object-oriented text-based video game. So you're going to have these objects, these constructors that you need to make. Your original constructor is going to be called game object, and it's going to have these 3 abilities. These 3. Well, it's going to have these are properties, and these are methods right there. So I've made sure if it's a method, it has parentheses on it. So you're going to be basically building these 3 objects out here, these constructor functions. I keep saying objects, but I mean to say constructor functions. These constructor functions will receive these objects. So mage, swordsman, and an archer. These 3 objects are going to be put into those 3 constructors, and they're all new humanoids, okay? So humanoid is a 3rd level inheritance. So in this case, we have a game object, which would be considered our parent today, our character stats, which would be considered child, and then humanoid is just another level deep. And so you just got to push yourself a little bit and understand what's going on with our call and object.create. So the inheritance chain looks like this: game object, character stats, humanoid. And so once you put them all together, you should be able to get all these console.logs to work. So basically, I've given you objects. If you build the constructors properly, you will get the results here. That being said, it's not quite a video game yet. So I've set up some fun stretch tasks for you today. So you're going to have to be able to create a villain and hero constructor functions that inherit from the humanoid. Okay, so first off, set up 2, a villain and a hero. Then give the hero and villain different methods that could be used to remove health points from objects, which could result in destruction if health gets below 0. So basically, you could console log, or you could run some methods where they fight each other. Isn't that cool? And then create 2 new objects, one of a villain, one a hero, and fight it out with methods. So you should be able to fight those things out. In the past, I've had students go a little bit further and actually make like image sprites that fight each other. It's been pretty crazy. But in this case, this really is the beginnings of how you could build a really simple video game, text-based video game. So don't be intimidated when I say video game. I don't want you to freak out. Ultimately, you're just trying to get some console logs to run. But if you want to push yourself, I highly recommend you try today to get to these stretch tasks. Okay, that's everything. I'm now going to go back to the question thread. But if you feel good about today, you're free to leave, go to lunch. If you want to stay for a little bit longer explanations, be my guest. Okay. So in the question thread, could you give a visual? So David asked about that visualization. Let me give that to you right now. So I'm going to grab my annotation tool here. All right. So in this case, specifically with parent.call, what we're doing is we have our child constructor, child right there. We're saying, I want the I want access to the this keyword of everything the parent has. So that's why we invoked parent. And so what we're doing is we're saying, okay, parent, I want all your this keywords. I want all this stuff up here. So that's what that line's doing. And then we're taking all of our child attributes, and they already map, right? Because they match. Age, name, location, phrase, and if rock was there, but again, this doesn't matter because it's only on Fred. But these ones do match, they check out. So these ones then are used in our child, and we can use them inside of anything inside of child, including our play method, which is below. So let me clear this, scroll down a little bit. So you can see we're using this.name. We could not use this.name if we did not have parent call. It's that important. And so having that binding of the this keyword allows us to use the this keyword that came from parent. Now, the thing that we needed methods for was our object.create and our prototype, right? Because these are built on the prototype. So prototype speak, prototype math. We couldn't speak or do math. And by the way, it's impressive that a 2-year-old can do math. But in this case, she can actually do math because we used object.create and then we accessed parent.prototype. So that is how that works. Hopefully that helps, David. A little visualization there. If we wanted to like really visualize it, we could zoom way out here. And I could just show you really quickly the chunks of code and where they link up. So first off, we made Fred, right? Fred was built by parent. All of his information was then made into an object. Then he gained these 2 extra methods by way of prototype. Okay, so that's Fred. Pebbles is then made. And with Pebbles, we have the innards of Pebbles, right? And so Pebbles gets called here in child. And what we're doing with parent.call is we're accessing all of the this keyword. We then have our own special unique that nobody else has named value pair, which came from toy, right? And so this is special. Special. Only child has. Parent doesn't have this. We just did that to show you why we would even make a child in the first place if we're just copy. Then to gain the methods, these circles right here, we don't have them yet. We can't access them. So we had to use this line to say childs.prototype. Well, remember what the prototype is. It's the guts between the curly braces. So that's what prototype is. We then say object.create, which we saw from MDN allows us to recreate an object using some other object's prototype. Well, what's the prototype of our parent? Well, it's all of our guts of our constructor and our methods. So now we gain access to all those through here. So all of these things combined now allows us to introduce our own methods down here that are unique to Pebbles. And that is how I would draw it out. Okay. Daniel says, does child not get access to the methods of parents specifically because they are methods or because they're not part of the parent? Oh, I answered that already, sorry. It's because they're not part of the prototype. And Randy as well, okay. Andrew says, so in the end, the child end up with more and more definitions as we get downstream. Does that equal bloat? It can equal bloat, yes, Andrew. So we have to be careful about how many inheritances that we introduce. But, I mean, look at array. Could you say array is bloated? I mean, look at this, right? It's a primitive, but it's still pretty dang fast. So we're talking like tons and tons of inheritance would have to make this bloated. For now, our silly example is not really bloated. It's too small. We're talking 4,000 lines of code. This thing could get really nasty real quick. Okay, Amber says, so can you inherit from a constructor that already inherited stuff from another and so forth, like a third level? Yes, you totally could, Amber. As long as you set up your binding correctly and your object.create correctly, you're good to go. Good question, Amber. Nathan says, if you do a third child level, okay, same thing. Do you bind to parent or child, or does it depend on whether you want to inherit the child prototype versus the parents? It all depends on what you want to do, Nathan. So if you wanted to have the play prototype, then you would just make a new function called grandchild, right? And then go on and keep building. But I'm not going to do that because that's your assignment. Okay. Leanne says, can you review why we create methods on the prototype and not inside the constructor function, especially concerning parent in your example, or clarify your answer to Hamza's question above? So Hamza's question above said, why don't you just do this? Why don't you just say that? And my answer to that is, well, because of this line right here, we have to create a new prototype reference. So we want to make sure it's on there permanently. Remember when I showed you the array example, when I changed on my computer only the primitive array permanently for at least that session? That's the same kind of concept, Leanne. So also, we want our constructor to have just properties in it. We don't want to have methods inside of this constructor. Because if you look at our constructors over here, like with array, see how the properties and methods are separated? Now, this is just documentation, but I'm saying in the code, they're separated. If we were to go console.dir, we'd see they're separate. So our methods, we want them to be out of our constructor and on our prototype for reusability. So that's the long answer. Okay, good. Okay, again, if this is super confusing, I expect it to be. It's a lot of information. Like, don't think you're a bad developer. Don't think that, man, maybe JavaScript isn't for me. This is harder than I thought. I want you to chew on the things that you do know and slowly step further into the dark, and more will be revealed. One step at a time, and more will be revealed. So if you need to go back to this keyword and study that a little bit, please do. Like, don't beat yourself up if you're just feeling a little overwhelmed right now, or a lot overwhelmed. I know I would be. So understand, my first time learning this stuff took a long time to wrap my head around it. So if you're having a hard time, again, keep pushing one line at a time, figure it out. But you have to push. Giving up is not what I'm talking about. So take breaks, do 45-minute increments of really hard study, and then take a 15-minute break. Like, do that this afternoon if it's kicking your butt. Okay. I won't see you guys tomorrow. I'm going to be gone tomorrow, Friday, and Monday. Work is taking us off to a work retreat. So we're all going to be in the same place learning how to be better employees and good people. So you're going to be watching a recording of me tomorrow, which you've already done before. So it shouldn't be, it's just more of me, just record it. Don't be sad. You're going to love tomorrow, by the way. Tomorrow is amazing because we introduced to you some fun syntactical sugar that I think you're going to love. So tomorrow, you're going to be watching a video. Then you'll have your sprint challenge on Friday. Caitlin will be running everything, your section lead. So she'll be releasing the video at the same time after, like, treat tomorrow like a normal day. So just make sure you understand that. Like, don't slack off, please. You can't afford to. Then Monday of next week, it's going to be the same thing because we'll be traveling back. So you need to make sure that you're watching the video for Document Object Model 1. I'm really excited for you to watch that. I wish I could teach it to you live. It's one of my favorite topics. I will then see you live again next Tuesday. We'll be talking about Document Object Model 2 in event listeners. Okay, so for me, have a good weekend. For you, please don't slack off. Push yourself. Again, I think this was the hardest day of the 5 weeks. This was a big one. But after this, it gets more clarity and more fun. So get excited. All right, my friends, talk to you later.